Good morning. Welcome to Mission Control Houston, the home of the International Space Station's lead flight control team. The shift on duty now, and the others that staff the consoles here 24/7, are keeping close watch on the station's systems and working with the Expedition 56 crew members to help them through the maintenance work and the science tasks on their daily agenda. Earlier this week, the station crew worked with the ground teams to capture an incoming cargo ship, attach it to the station, and then get inside and start unloading the thousands of pounds of supplies, including science and experiment hardware, making its on-orbit debut.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Ryan Stewart. You want science? How about the 17 NASA payloads just added to the International Space Station with the birthing of SpaceX Dragon 15? After 3 days of circling the Earth with ground teams in Hawthorne and Houston watching its every move, Dragon was captured by NASA astronaut Ricky Arnold. The spacecraft, carrying nearly 6,000 pounds of cargo, was attached to the Node 2 Harmony module, about 250 miles higher than it was a few days before. Along for the ride and now joining the station crew members is Simon, a crew interactive mobile companion. Simon will be the first artificial intelligence-based assistant used on station. Its primary design is to help with routine tasks. However, thanks to its neural AI network and ability to learn, Simon may very well offer solutions to onboard problems should they occur. In order to serve as a test case for the new technology, the first mission for Simon will only utilize a selected range of capabilities. If all goes well, AI-based assistants like Simon will be a critical part of long-duration human spaceflight in the future. Until then, only time will tell what Simon says. This week's Twitter question comes from Ozzy, who wants to know how we keep track of where we are in space. This is a great question, and you'll find out that it's not that different than what you probably use on a daily basis. Your position in space is part of what is known as your state vector. This includes your position and velocity in 3 dimensions and time. The International Space Station acquires its state vector and thus position using GPS, not unlike your smartphone. Using signals from GPS satellites above, the computers on station can figure out where it is with respect to Earth and which direction it's heading. In fact, the same signals are used to determine the orientation or attitude of station. So next time you find yourself navigating via GPS, just know that the International Space Station is doing the exact same thing. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
Off the Earth, for the Earth. Space to Ground.
The station is due for another delivery of supplies this coming Monday, July 9th. NASA TV and NASA.gov will have live coverage of operations on orbit and on the ground. Coverage begins Monday, July 9th at 4:30 p.m. Houston time, and the 70th Progress ship bound for the International Space Station is due to launch from the Baikonur Cosmodrome in Kazakhstan at 4:51 p.m. We'll be back on the air at 8 p.m. Central Monday night to watch 70P link up to the Russian segment's Pirs docking compartment. That should happen at 8:39. This cargo ship will remain at the station until late January next year. Robotic technology, originally designed for the International Space Station, has found a new application in healthcare as part of a telerobotic technology to provide MRI-guided breast biopsies to women in remote areas. The Canadian Space Agency contributed to the production of this feature about the innovations coming from the Centre for Surgical Invention and Innovation in Hamilton, Ontario.
Space represents a fairly harsh environment. Any piece of equipment that's exposed to it over a long period of time would require maintenance.
So every time we have to do a maintenance on the outside of the space station, that means a crew member has to suit up and go outside. That introduces that crew member to risk and puts that person in harm's way. The other issue is that now they're spending the time doing the maintenance work, and they're not doing the science, which is really what their purpose is. So with the maintenance challenges that we were going to have with the International Space Station, what we found ourselves was Canada being in the position to provide a solution to that problem, and Dexter was going to be that solution.
Dexter is a 2-armed robotic manipulator system capable of performing fine motion tasks to replace what an astronaut would need to do on the exterior part of the space station.
Dexter is essentially a handyman. It operates on the outside of the International Space Station. It allows us to do maintenance operations. One of the advantages with Dexter is that we're able to control it from the ground. ground.
And so the ground crew could actually operate these robotic systems and free the astronaut up from that task as well.
So now that Dexter's online on the space station and operating on a regular basis, what we've got a crew who's spending more time doing science. And this is important because this was really the whole idea of building the International Space Station, was to be able to do science in low Earth orbit.
Unfortunately, only about 40% of women should be getting annual MRI as part of their screening undergo MR screening. Part of the reason why women were not undertaking MRI screening was because of lack of access to the best radiologists locally.
Some women have to drive very long distance, like 7 or 8 hours of car in snowstorm during the winter, sometimes risking their lives just to get their MR-guided breast biopsies.
When we started to do the research with Canadian Space Agency and NASA on the whole remote telesurgery, we started to get involved with MDA. MDA is a Canadian company which has been involved in manufacture of all the robotic systems which is currently used on the space station.
So we developed a system called IGAR, which stands for Image Guided Automated Robot.
IGAR is a tele-operated robot that performs breast biopsies under MRI guidance.
One of the capabilities of IGAR is to be controlled by radiologists from any distance. And that allows basically radiologists to supervise MR breast biopsy on a patient who may be hundreds of kilometers or thousands of kilometers away from them. It means that the patient can undergo their breast biopsy in their own local hospital without having the need to travel to another city or another hospital to get access to the expertise.
And the results are very, very encouraging. So we've demonstrated that the IGAR is safe, extremely accurate as a human.
And this will allow us to hopefully increase the number of people undergoing screening close to 100% where it should be. So IGAR is built on many of the know-how which was developed for the space program, as well as the software which is also used to control the robotics on the space station.
We can actually see some of these technologies we worked with for a long time becoming available. We have a lot of insight on how to apply them, not just in medicine, but in a number of other fields, which is what we're doing. So without the space station, would any of that have happened? No, not really. Not in that way, anyway.
For many station experiments where the crew members are the test subjects, there are biological samples that need to be preserved on orbit before they can be returned to Earth for study. So where do the astronauts and cosmonauts store their lab results? Well, in one of a dozen large freezers, of course. In this Speedy Time segment, astronaut Jack Fisher shines a light on the Melfi, minus 80 degrees laboratory freezer for ISS.
Hello and welcome to another Speedy Time. Today we're going to talk about one of the most useful tools we have on the space station, the minus 80 lab freezer ISS, Melfi, or as I like to call it, the freezer of awesomeness.
The space station is for science, and we want to get all these samples we take back down to the ground. To do that, we need a big freezer, and that's why we have this baby. It uses a Brayton cycle with a wee little motor spinning at 87,000 RPM. That's fast. To get these freezers down to almost 100 degrees below zero. There's 4 75-liter chambers in each Melfi, and we have 3 Melfis. We have a bunch of other little freezers too, but this is the big daddy. So it's so cold, we have to wear these fashionable white gloves. Do you remember in A Christmas Story where he stuck his tongue to the flagpole? That's pretty much how it is if you put your hand on one of these. So to get samples back down to the ground, the Melfi cools down these wonderful little things called ice bricks. And then we put these in these super coolers and then send them back to the ground so that all of our science can be studied, and hopefully we find some cool results out of our experiments. I actually have a sample that I have to put in one. But to make it more dramatic and awesome, we've turned out the lights and we have backlighting so it'll just look cool. Come on, let's check it out.
And that, my friends, is the awesome super freezer that we have on the space station. Hope you learned something. Have a great day.
In addition to the human life sciences on the agenda, researchers using the International Space Station hope to learn more about the physical sciences too. For example, researchers behind a number of experiments on the science of combustion hope to find out ways about burning fuels so that the process produces less pollution.
The power of studying combustion on the ISS. Presented by Science at NASA. If you wanted to reduce the amount of pollution humans produce, where might you look? Here? Yep. Here? Sure. Here. Wait, what? That's exactly where scientists and researchers are looking, about 250 miles above Earth on the International Space Station. Here, astronauts are working on a series of experiments to learn more about combustion. Why combustion? Dennis Stocker, project scientist for the Advanced Combustion via Microgravity Experiments, or ACME, says, consider this. About 85% of the energy we use comes from combustion, the burning of some sort of fuel. About 70% of the electricity that we use at home and work comes from power plants that use combustion. The combustion of fuels powers the engines in many modes of transportation. Stocker continues, if we can learn more about the process, we might be able to find newer and less polluting ways to burn fuel. 3 series of combustion experiments taking place on the International Space Station's Combustion Integration Rack, or CIR, are looking at combustion in very different ways. The Flame Extinguishment Experiment, or FLEX, examined the burning of a single droplet of fuel in the microgravity confines of the ISS. The last of the droplet combustion experiments were conducted in September 2017. ACME began in November of 2017. ACME is composed of 6 major experiments, with each taking about 5 months to complete. These experiments will examine how various gases burn without gravity affecting the flames. The Solid Fuel Ignition and Extinction, or SOFI experiment, will explore the properties of burning solid matter. So why study combustion in microgravity? As Stocker explains, on the ISS you have conditions that you can't replicate on Earth. For example, consider a candle when it's burning. The flame flickers. Why? Hot gases from the flame rise, while cooler, denser air is pulled to the bottom of the flame. This flow occurs at high speeds, resulting in turbulence and instability. That instability makes it hard to study the properties of the flame. But on the ISS, there's no flicker, which allows us to make more precise and consistent measurements. If we have precise measurements, we get closer to learning how to burn more efficiently. More efficiency could lead to real cost savings for producing power. The research could also lead to reducing the production of soot and other pollutants. Combustion experiments conducted in space have contributed to practical applications on Earth, especially in the field of fire safety. A new type of fire extinguisher is just one example. And as Stocker notes, I think we're in for a few more surprises as a result of these microgravity experiments. That's because, not surprisingly, Stocker knew where to look for answers to reducing the amount of global pollution. He looked up. For more from the International Space Station, go to www.nasa.gov/station. If you're burning to learn more about other hot science topics, visit science.nasa.gov.
Along with hands-on work with science experiments, International Space Station crew members use some of their time for educational events in which they talk about science with students on Earth, talk about the mission, share the value of learning about science, technology, engineering, and math during this year of education on station. Explaining STEM topics to students is an important part of the station's education mission. In this STEMonstration video, Randy Bresnick demonstrates Newton's second law of motion.
I'm astronaut Randy Bresnik, living and working aboard the International Space Station. Now, on the space station, we live in a microgravity environment. Do you think the laws of physics will hold up? Come on, let's go find out.
The acceleration of an object depends on the net force acting on the object and the mass of the object, or F equals ma.
Jolly good show, Sir Isaac.
Here we see that once the force of the thrust is greater than the weight of the vehicle, the rocket begins to accelerate.
All right, we're going to start with something small. Something you might have at home. A little stick of chapstick. We'll go ahead and use our force, being our bungee cord here. We'll put it on our bungee, and we'll pull it back. And let it go. And you can see how fast it accelerates because there's very little mass. Next, we'll try a little spaceship. A little more massive, and you can feel that because as you move it, you can feel that the kind of the force, the extra force you have to push with your hand. So we'll put our spaceship on our launcher here, same spot. Notice it's flying a lot slower than that chapstick did. What we've seen is the same amount of force on a smaller, less massive object means the acceleration is faster. Well, this is the biggest and most massive thing we have, so let's see how the acceleration is affected. Pull back the same amount on the force, and here we go. And there you have it, Newton's second law of motion in action. Thanks everybody for exploring a little physics with me today. Now I'm going to send it back to Earth so you can start your experiments. See you again real soon.
Astronaut Ricky Arnold is tapping into his experience as a classroom teacher to support the year of education on station during this mission. It turns out Arnold's path to becoming a teacher was influenced by an educator who he never met after he'd already finished college.
I enjoyed teaching different subjects because it was an opportunity to learn about different things. I always thought that was one of the greatest deals about teaching is you get to learn alongside students. Yeah, it wasn't a single point in time where I really decided to become a teacher. I was right out of university. I was working at the Environmental Protection Agency. I was actually out at lunch and was on my way back in. And on the television was the Challenger accident, and we lost Challenger that day. But I guess having a teacher on board that mission was very personal. Everyone knows a teacher. I thought it sent a pretty powerful message as to what NASA thought of the teaching profession. They recognized then that there's some really talented people working in our nation's public schools. And that kind of planted a seed about, that's a really kind of a unique profession that I hadn't really considered. And kind of a confluence of events kind of shaped my decision to go into teaching. And it was a really rich and rewarding career. There's a lot of things I'm looking forward to going to the International Space Station. One, I got to help build it, and now I get to go live and work there. You may know Joe Acaba is currently on the International Space Station, and he and his crewmates have been doing some STEM demonstrations from orbit, demonstrating STEM subjects from the International Space Station, which is a fantastic platform for education. Going back to the Challenger mission, I've always kind of wondered what was Krista going to do while she was up on orbit. And that mission, unfortunately, was never completed. But we're going to have the opportunity with our crewmates to kind of bring that mission full circle. And we're going to actually conduct some of Krista's lost lessons that never had the opportunity to do because of the Challenger tragedy. To me, it's for our nation. It's really important that wasn't lost. Free of gravity, the demonstrations in physics, the principles surrounding gravity are really easy to demonstrate in fun ways. So I'm hoping that we can package up some nice stuff that teachers can use as a resource long after we're home and long after the mission's over, that the education and the tie into the space station will continue. Hi, my name is Ricky Arnold. I'm a classroom teacher and a NASA astronaut. And I'm getting ready to go to the International Space Station again to fly as part of the crew of Expedition 55 and 56.
Ricky Arnold arrived at the International Space Station along with Soyuz Commander Oleg Artemyev and Expedition 56 Commander Drew Feustel back in March. The two NASA astronauts had made 3 spacewalks together since then. For Feustel, that's 9 spacewalks in his career and more than 61 hours spent floating outside in space in his lifetime, which is a little surprising for an astronaut who's admitted to a common fear that nevertheless is unusual for someone in his job.
The first thing you might not know about Drew Feustel is I actually hold dual U.S. and Canadian citizenship. It's true that that association is through marriage, but I can tell you that the family of my maternal grandmother actually immigrated to Canada from the U.S. So there's that. I taught myself how to barefoot water ski at the age of 14. And I can tell you that I've swallowed a lot of lake water because of that special skill. You're going to like number 3. I actually have a mild fear of heights, but apparently that doesn't affect me 250 miles above the planet in a spacesuit, but it is there. My wife, Indra, and I have 2 boys by the names of Ari and Aiden. They were both born on the exact same day, exactly 2 years apart, on April 26th in Kingston, Ontario, Canada. Natural birth. That's what I call planning. I grew up with 2 dreams in my life. The first was to become a Formula One race car driver. The second was to become an astronaut.
One goal of the International Space Station's science is to figure out the impacts of the space environment on the people who spend extended periods of time there, which of course is going to be the case for crews on future missions that go far away from Earth. One of the hazards confronting those future crews will be the radiation those men and women will encounter on the trip. NASA's Human Research Program has been looking into several ways to try to shield astronauts from galactic cosmic radiation.
Just as early explorers had to endure weather as they traveled to new lands and explored new areas, astronauts, when they go on space travel outside the Earth's magnetic field, will have to endure space weather. This space weather would include things like galactic cosmic rays, which are remnants from supernova, and also solar storms, which include things like solar particle events and coronal mass ejections. So as astronauts are traveling to Mars, they're going to be enduring the space weather, and it's harmful to the body in a couple different ways. There's an in-flight risk from things like solar storms, and those really present acute radiation sickness type issues that would have to be dealt with operationally in real time. And then there's also long-term late effects like cancer, cardiovascular disease, and possible central nervous system effects. And those are more possibly late-term effects that would come into play after the mission. So just like the early explorers, NASA's mission is to bring all of the astronauts home safely. And to do that, we're investing and looking into these shield design strategies that include ways that mitigate exposure from all forms of space weather. So we look at habitat design and overall vehicle optimization to reduce the in-flight risk from solar storms. But then we're also looking at material design and other vehicle optimization strategies to reduce the risk from long-term exposure to galactic cosmic rays.
The International Space Station is all about science, all about supporting future exploration too, including things like learning how to fix things on orbit. The station's also about promoting international cooperation, and it's a key element in NASA's effort to promote the commercialization of space flight and space research as a destination on orbit and a laboratory that supports cutting-edge science and technology research and development.
With every day on orbit, the International Space Station changes the way the commercial sector thinks about doing business in space.
After the designation of the ISS National Laboratory, we saw the emergence of small startup companies, commercial entities that were making a business out of doing research and technology development on the space station.
The space station needs supplies delivered, so NASA encouraged private companies to look into the space freighter business.
The key precursor was the completion of the space station to have a destination in space where it made sense to apply competitive commercial activity.
If you know that you've got a contract that could last for years and that program such as the ISS will actually benefit from it, it motivates both sides to put a lot into it and make sure it's successful.
Being in orbit 250 miles above the Earth, the station is a launching pad for small satellites.
If we didn't have access to the International Space Station, we wouldn't have nearly as frequent access to space, and that would have set back our ability to rapidly iterate our technology.
And now today, we're able to operate the largest fleet of Earth imaging satellites in human history.
The weightless environment is ideal for laboratory science that can't be done on Earth.
The International Space Station offers researchers like me an opportunity to find the key variables to crystal growth. And these crystalline suspensions have applications such as manufacturing, drug delivery.
We're looking at a new molecule that has some very interesting properties in muscle wasting, and it counters muscle wasting diseases.
And with the station as a commercial destination, there's a business to run arranging the transportation.
We've flown over 200 experiments to the space station, everything from plant growth to silver plating to slime molds growing in space.
The International Space Station is powering private expansion into the cosmos and enabling future deep space exploration, fostering international cooperation, and generating benefits right here on Earth.
If you'd like to get another look at any of the stories we feature today, check us out on YouTube and on Facebook. There are the addresses in the nice blue box on the screen. And while you're at either one of those spots, take a look at all the other great stuff you can find there about NASA and America's human spaceflight program. And if you're interested in good conversation about space exploration, check out Houston, We Have a Podcast. It features folks here at NASA talking about their work, their experiences on the job. New episodes post on Fridays. And today, July 6th, marks 1 year since the first episode posted. So, Gary Jordan and the other folks in our office who are responsible for meticulously handcrafting a year's worth of award-winning podcasts all get together in front of the mics to talk about the highlights. A good time will be had by you if you go to www.nasa.gov/Johnson/HWHAP, Houston, We Have a Podcast. You will find the birthday episode there amongst all the other episodes. You can also listen on iTunes, Google Play, and SoundCloud. This is Mission Control, Houston.